Hi, welcome to my video on changing an exponential function to a log function, extra 1. But before I start this video, I want to go over an error that I made in video number 7. And in question mark number 11, the range of the log function is the set of all y's as y belongs to the reals. This was what I wrote. But then I made a statement that the domain of the exponential function is the set of all x's that x belongs to the real. And I didn't say that I thought I said the range of the exponential, but the answer, the range of the log is the domain of the exponential. So it belongs to the reals, belongs to the reals. The range is the y, domain is the x, and both of them are the same, but they're belong to the reals. So I made that error. I just want to correct that. So let's change the exponential function to a log function. Change each to log function. In other words, we're trying to find f to the negative 1 of x. So the first step we do, we change the f of x to a y. That's done. When we change the f of x to a y, we interchange the y to an x and an x to a y. So we made the f of x a y, and then we interchange the y's and the x's because there's a reflection in the line y equals x. So y is x, x is y. Now, I want to just go over PEMDAT. When we're finding an inverse here, normally when we do the order of operations, we do brackets, exponents, multiplication, division, that's a D there, multiplication, division, addition, subtraction. But when we're doing the inverse, we work backwards. That is, we do the addition, subtraction, then we do the multiplication, and then we do the inside the brackets and exponents. So what we do, we move the plus 3 to a minus 3. And notice now that we have the base exponent number. So when we write the log, the base is 2, the exponent is y minus 1, and the n is x minus 3. So we write the equation in the exponential form, and then we convert it to a log. So now we have log base 2 of n minus 3, and we move the negative 1 to the left side to make it a plus 1. So now we have the equation y equals log 2 x minus 3 plus 1. And that's the inverse of the exponential that we started with. So this is the f of x, which is an exponential. This is f to the negative 1 is inverse, which is a logarithmic. And sometimes what you need to do is check. How do we know if we're right? Well, let's check with the f of x. If we take the f of x and we say, let's say x is 2. If x is 2 in here, the f of 2, 2 minus 1 is 2, 2 to the 1 is 2, 2 plus 3 is 5. So if we look at the f to the negative 1, that means a 5 should give us a 2 because it's reflected. Reflection in the line y equals x. X is y, y is x. So if we take this log equation and put 5 in the place of x, so if I put 5 right here, 5 minus 3 is 2, then 2 to the what power gives me a 2. The answer is 1. So the log of 2, base 2 is a 1, and 1 plus 1 is 2. So that tells me that the inverse of this exponential is this logarithm. And let's try another one. The f of x equals the negative 7, bracket 3 is the base, raised to the 2x plus 1. Again, we make the f of x equal to y. Let me write out the equation. We interchange the x and the y. Y is x, and x is y. And we have to put it in the exponential form, but we have the -7. We divide by -7, -7. So that gives us a -1/7x equals 3 to the 2x plus 1. So now we have a base and exponent, and this is the number. So in log form, log, the base is 3, the exponent is 2y plus 1, and we have -1/7x. Base, exponent, number, B-E-N. And now we have to solve it for y. So we bring over to 1. So we got the log 3 -1/7x minus 1. Remember, we're doing the opposite, so we're getting rid of the here. We divide it by -7 to isolate this power exponential. Now we have to solve it for y, so we move the negative plus 1 first to the left side to make it negative. Now we divide by 2. So divide by 2, divide by 2, so we get, that gives us 2 parts here, so it's a half log base 3 -1/7x, and 2 into 1 is a half, and that's the y. So we have the equation y equals half log 3 1/7 x minus 1/2. Notice that this is in brackets, and I just want to show you that it's important. Just on the side, this is on the side, the log of 4x minus 1, that's not the same as the log of x base 4 subtract 1. Notice this is in a bracket. So this is the log of x minus 1 base 4. And right here, this is the log of x base 4 subtract 1. So when there's no bracket, that's understood to be a subtraction. But this whole expression, this binomial, is a number. But right here, again, notice the difference between this one, x minus 1 is the number. Here, x is the number. And we're doing the log of x base 4, then subtracting 1. There is a difference. And we check. We check to see if we're right on the f of x. Let's check with the point when, what happens when you get x is 0. So I'm just picking 0. I could pick a 1, I could pick a 2, -1. When x is 0, so 2 times 0 is 0. 0 plus 1 is 1. 3 to the 1 is 3. -7 times 3 is -21. So this is the number that fits the f of x. So what about f to the -1? That means we should have the number -21, 0. So let's, I forgot, I just noticed now that's a negative there, and I got careless and dropped the negative right there. So if I take the -1 and take the -21 and sub it in, I forgot to write, working ahead of myself. This is why I forgot to write down the inverse f of -1 notation. So we plug in a -21 right here. -1/7 times -21 is a 3. And 3, the log of 3 base 3 is a 1. A half times 1 is a half. And a half minus a half is 0. So again, this fits. So I checked it with this. This point satisfies the exponential, and this point satisfies the logarithm. So that tells me I have the inverse done correctly. So there's a couple examples of changing an exponential to a logarithm, which is the inverse. And if you like my video, click on the like button. If you're not a subscriber, click on the subscribe button if you wish, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.